How are you, my friends? This video is presenting 6 old exams questions related to graphs of functions. Now, the first one, given the greatest integer function, f of x, square root of 200 minus 2x outside plus 2k minus 3, find the value of k if the image of 3 is 12. So when we say the image of 3 is 12, so 3 is the x, and the 12 is the y, and y always f of x. So f of 3 is 12, then x we know 3, so I can replace 3 there in the function, see, and y is 12. Now I simplify 10 square root of 2 is square root of 200, 1.41, we know square root of 2 just 1.41 times 10, so 14 minus 6 is 8.1. The greatest integer here is 8. Okay, so 2k, 8 minus 3, 5. On the other side, 7 over 2k. That's it. Now, question number 2, which of these relations is a function? We have 1, 2, 3, and 4. You have to go slowly and check. 1, 2, minus 2, 5, 8, 0. Y squared is equal x plus 10. Y equals x plus 4. The third one here is a straight line. This one is a parabola, but y squared. Y equals square root half parabola. So maybe number 2 is not a function. See here, y squared. If it is y equal x squared, it's a function. And this one is not a function, number 5, because we have 3 has 2 images, 3, 4, 3, 6. This is a function, this is a function. Graph the piecewise function. We have done that in lecture 28, algebra course. You can check that there, please. F of x has 2 pieces here. State the domain and range, and find x-intercept and y-intercept. So we have to do 5 things here. Graph it, domain, range, x-intercept, and y. So the idea here is I take piece by piece, minus 2x plus 5, x less than or equal to 2. So I take it there, see the first piece here, x less than or equal to 2. So I take some numbers because this is a straight line. So I start with 2. Put 2 there in the function, 2, that will be 1. If I put 0, it will be 5. So 2, 1, you see 2, 1 here, 0, 5 there. 2 points enough. Join the line because I know this is a line because x power 1, y power 1. Now, the second piece, x plus 1. X greater than 2. Be careful here. There is a little trick. X greater than 2. So the important question, which number we start with? 2. But we make it open. So I put 2 there in the function here, 2 plus 1, 3. 2, 3 is the first point open, not included, because there is no equal here. Then I take another point, greater than 2, I take 5, becomes 6. So 5 and 6 is there. So I join the line. Now, find the domain or real numbers. You can find the domain actually from the given. See, it covers all the x. Now the range, it will be starting from 1 or closed until infinity, all these y's values. No x-intercept here we can see, and the y-intercept only 0 and 5. Now graph the piecewise defined function. Another function, 2 pieces. Very nice because we have absolute value. So we graph it, we state the domain and range, we find the number of x-intercepts. Now we have x, absolute value of x less than or equal to 1. That's nice in the condition. So to graph this function, we start with the condition here. Absolute value of x less than or equal to 1. So we can remember lecture 26 in the algebra course. There are 3 cases. Case number 2 is about absolute value less than. And case number 3 down here, lecture 26, will be for the absolute value greater than 1. And just to remind you, case number 1 will be absolute value equations, which is not in this question. So absolute value of x less than or equal to 1. Then directly we say x between -1 and 1. So I go to the graph between -1 and 1, and then I draw this function here, the first piece, x squared. I know x squared will be the whole parabola, see? But now this is restricted or limited between -1 and 1. So I draw only this part of the parabola. Second one, absolute value of x greater than 1. You see the condition there in the question. So x less than -1 or x greater than 1. You have to use the word or. That's the graph is a constant, line y equals 3. So at 3 I have a line, but remember the condition, less than -1 open and greater than 1 open also. So this is a line constant, line constant. That's the graph. Now the domain or real numbers, it covers all the x values. The range only from 0 closed until 1 closed. This is the values of the y union the 3, because the range are the values of the y and the domain are the values of the x. Number of x-intercept 1, which is at 0, 0. Now question number 5, which relation does not represent a function? X plus 3y is equal to 2, y is equal to 6 minus x squared, xy is equal -4. Which one is not a function? I think the e is not a function. X equals 10 minus y squared. That's a parabola opens to the left. See, like this. If you draw a vertical line here, it cuts in 2 points, not function. This is horizontal line. This is rational function, you know. Y equals -4 over x. This is a parabola. This is a straight line. Question number 6, also back to the graph. Given the piecewise function, find the x-intercept and y. It's better to graph it also here. And then where the graph is below the x-axis. So it's better to graph it. We have two pieces here. X between -1 close to 0. This is 1 plus x. Another parabola here. If x is greater than or equal to 0. Take one by one, as we did before, and graph it. Let's see. So I take the first one, y equals 1 plus x, x between closed -1. So I start with -1 to 0. If I put -1 there, it will be 0. If I take 0, see, if I take 0 here, 1 plus 0, 1. But this is open, remember, no equal. So that's the graph. See, only between -1 and 0, that's the line. Closed at -1, open at 0. Now, let's see the second one, x greater than or equal to 0 here. So I take 0, okay, 0, put it there, -1, 0, -1 there. This is the point in the graph. If I take 1, it will be 0 here. If I take 2, 4 minus 1, 3, so 3 there, 2, 3. So this is the parabola here, half, because why? X greater than or equal to 0. Now that's the graph. Let's see. How many x-intercept? We have here x-intercept, -1, 0. There's another x-intercept, 1, 0. Y-intercept is 0, -1. Where the graph is below the x. See, this is the x-axis, below the x. Below the x, this is a closed point, see it at 0. So we take only the interval on the x-axis. So that's 0 closed. Below the x, 1 open. We have to make 1 open because it's under or below. Now, these are the answers that we put for the 6 questions. For more examples, please, you can see the video on Algebra course lecture 28, which is graphs of functions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you very much.